In this video, we will be working on finding the volume of 3D figures and also applying that knowledge in creative ways, different questions that are really going to help you prepare for standardized testing. So what is volume? Volume is the amount of space that an object occupies. If you think about the volume of this cup, I'm thinking about like how much water does this cup hold, right? So if I fill the cup with water, that is demonstrating volume. We know area is like planting grass, and how much grass would it require to plant to fill this whole area of the football field. And we know perimeter, so this is area, and we know perimeter is, how far would I have to walk around the field. So perimeter is going around. Volume is filling up. Volume is all of this inside, but it's three-dimensional, right? So it has a length, it has a width, it has a height. So all of this is volume. All right, so the formulas for cones, cylinders, and spheres are here. A lot of the problems might ask you to leave your answer in terms of pi, and then they might ask you to also round to the nearest tenth or the nearest hundredth. Make sure you read directions carefully and always leave your answer in the appropriate form that they ask you for. So get down these formulas. I wouldn't expect you to memorize them, although after geometry, after taking a geometry course, you should understand why these formulas are this, and you will start to remember them a little easier. For your sake in 8th grade, you will be given formula sheets and you should be able to apply them. Okay, so number one, given a cone, the first thing I would do is make sure you write down the volume for a cone. So the volume formula for a cone was 1/3 pi r squared h. It says given a cone with a radius of 2 and a height of 6, and notice those are both in inches, so it's not like we have different units or anything like that, find the volume of the cone. Give your answers both in terms of pi and as a decimal, rounded to the nearest tenth. So guys, for finding the volume here, all we're going to need to do is substitute. Volume equals 1/3 times pi times 2 squared times 6. I would simplify all the numbers that you see first. Order of operations, 2 squared is 4. And then I would do 1/3 times 4 times 6, and I could do those all at once. I know that 1/3 times 6 is 2, and 2 times 4 is 8. So I get that my volume is 8 pi. There is your answer, but don't forget units. Remember that volumes involve 3 dimensions. We actually have radius times height. That means you have inches times inches times inches. So our answer should be inches cubed. That answer is left in terms of pi. Then to find your answer as a rounded decimal, you could simply take that 8 and multiply it by pi using your calculator, which is about 3.14 if you don't have a pi button. If you have the pi button, both will work. You should get approximately 25.1 inch cubed. So both of these are answers that we would want. One is in terms of pi, that's this one, and the other one is rounded to the nearest tenth. I should specify that since it says use 3.14 for pi, we should not use the pi button on your calculator. Instead, you should actually use 3.14. It will keep your answer close, but if you use the pi button, it might be slightly off. Okay, for number 2, given the volume of the sphere now. So actually now we are given the volume. This is the volume. Find the radius. So the volume formula for a sphere is 4/3 pi r cubed. You know the volume. So let's put that in for volume. 36 pi is equal to 4/3 pi r cubed. Isolate your r by undoing anything that's happening to it. For instance, I can see that r is being multiplied by pi, so I could divide both sides by pi. They cancel each other. R is also being multiplied by 4/3. So what could I do to undo that? I could multiply by 3/4. Multiply by 3/4. That's going to cancel. I like multiplying by the reciprocal. And you will have a calculator, so you could use that. I could do this on my own. This is going to give me 9, and 9 times 3 is 27. Last step, what is the inverse operation of cubing? R cubed could be isolated by taking the cube root. If you take the cube root of both sides, you would end up with R equals 3. On all geometry problems, always look for a label on your answer. We're finding the radius. The radius would be meters, not meters squared, not meters cubed. The volume was meters cubed. The radius would be meters. So my answer is 3 meters. Okay, great. Let's look at some more interesting problems then. A cake box in the shape of a cube. So cube has 3 dimensions. It has a length, a width, and a height. A cake box in the shape of a cube has a volume of 575 cubic inches. The length in inches of one side of the cube can be found by solving x cubed equals 575. So they are actually giving you the volume. They're saying, hey, this is equal to the volume. And if you wanted to find one of the lengths, the length, the width, or the height, they're all the same for a cube, you could find x. So x stands for the length. Now this question gives you a bunch of lines though, and it says which point on the number line represents the length in inches of one side of the cube. So let's take this. X cubed equals 575. How do you get x by itself? You would take the cube root of both sides. You could use your calculator here. So the cube root of both sides, cube root of 575 is going to come out to be about 8.2. Use your calculator for that. Now, which one of these number lines represents about 8.2? Well, a little bit more than 8, but not more than 9, right? So this number right here would be about 7.8-ish. This number right here would be about 9.2. Around. This number here would be about 6.5. So the first one is just a little bit more than 8. It's probably going to be the side length that we're looking for. It's the closest one. So my answer is A. Looking at problem number 4, it says the height of the cylinder is equal to the distance between points X and Y. So I don't know what the height of this is, but I could find the distance between X and Y. How could you find that distance? Well, you could always use a Pythagorean theorem. Draw in a right triangle. You could use the distance formula as well, but I think we don't quite know that yet, so we could use the Pythagorean theorem here. If I make this a right triangle, I can see that this, counting the boxes, is 1, 2, 3. I can see that this, counting the boxes, has a side length of 4. So I'm just going to pull that triangle out over here. Right triangle. I just am enlarging it so you can see it a little bit better. If I want to find this side, that is my C. So use the Pythagorean theorem to do so. Three and 4 are A and B. It does not actually matter which one's which, but C must be the hypotenuse across from the right angle. Now that I know that my distance here is 5, and I know that the height of the cylinder is equal to the distance, I know that my height is 5. And it's in inches. So it says, find the volume of the cylinder. Looking at your formula sheet, the volume for the cylinder would be pi r squared h. And now all you need to do is plug in. The radius is given to you as 2. Remember, the radius is from the middle to the side. So if they had given us the whole way across, that would be the diameter, not the radius. We're going to square that, and we're going to multiply it by our height. Do all of the numbers first, and do your order of operations. Here it says leave your answer in terms of pi, so I get that the volume is 20 pi. Never leave a naked geometry answer, so we always need units. Put a word on the end of that. Volume is always cubed. This was in inches, so it's inches cubed. No naked numbers. We need labels. Okay, last problem here in this lesson. It says, for which radius, r, would the volume of the sphere be about the same as the distance between point A and B? So you need to know what the distance is between point A and B. Again, how can we find that? Pythagorean theorem, great. Set up a right triangle, count your legs. Remember, a squared plus b squared equals c squared. A and b can be in different spots, but c must be the hypotenuse. To get c by itself, we would square root. And now you know the hypotenuse is 10. It says for which radius, which r, so I don't know the radius, would the volume of a sphere, the volume of a sphere is 4/3 pi r cubed. But I want to know where the volume is about the same as the distance between these points. Guys, that means the volume is 10. Substitute 10 in for the volume. Isolate r. You can use your calculator here, and it says use 3.14 for pi, so I'm going to put that in. I would multiply this on my calculator and get 10 equals about 4.2 r cubed. Now I can divide by 4.2. And I know that 2.4 is equal to r cubed. How do you get r by itself? Not the square root this time, but the cube root. Use your calculator, and you will find that the radius should be about 1.3. Now, which of your multiple choice answers is closest to that? And the radius would be with units on there, but we don't know if this is inches or anything like that, so we'll put units. But the best answer that is closest would be B.